in this next section, we are going to talk about regular deposits or payments. It's a little bit different than compounding, because in a regular payment, you're actually periodically adding the same amount to an investment. So you're adding something every single time. So in order to understand it, let's get into a question. First example, Courtney's saving a trip to Australia in 5 years after she finishes university. She plans to work on a student visa while she's there. She wants to study the fascinating migratory patterns of a rapidly dangerous koala bear. Well, just so you know, the koalas are not actually dangerous unless they're provoked by a human. Yeah, I just want to try and be funny. Now, fortunately, oh, little typo, should I also have a in bracket there. Fortunately, she needs to only pay for her return flight and her expenses until she finds a job. She deposits $500 into her savings account at the end of each 6-month period from what she earns as a server. The account earns 3.8% compounded semi-annually. How much money will be in the account at the end of 5 years? How much of this money will be earned interest? So the question is asking, if she's able to deposit $500 every single 6 months, how much is she going to have? The great thing is this formula has the exact same kinds of variables. It's just using a few things differently. The R is just whatever that regular payment or regular investment amount is. A is still the future value. In this case, she's depositing $500 every half year. A rate, 3.8%. And it's compounded semi-annually, which means that our end value is 2. So 2 at the end of 5 years, which is our time. As I said before, it's really nice. Anything that you have as an exponent, evaluate right away. But it's being divided by this R over N. So it's being divided by 0.038 over 2. What some people may need to do in their calculators is put this into brackets so that it all actually works out. As long as you put in enough brackets, you are able to type all of this straight into your calculator. For example, right here, I'm going to have to put 2 brackets. Divide by 2, the power of my 10, subtract the 1 more bracket, divided by, in brackets, my 0.038 divided by 2. We get $5,449.90, correctly rounded. So that's how much she would have in her account. The question is then asking, how much money will be interest? So how much is interest? Well, if she's able to deposit $500, oh, sorry. She's able to deposit $500 2 times a year for 5 years, she will have deposited $5,000 into her account. So $5,000 is how much she has actually put into her account, and the account is worth $5,449.90. Of course, I know that many of you would be able to do this in your head. I'm just making sure I show the work. But $449.90 of it would be interest. And that's how it's done. The next question. Adam made a $200 payment at the end of each year into an investment that earned 5% compounded annually. Blake made a single investment at 5% compounded annually. At the end of 5 years, their future values were equal. So what is the future value? So the first bit of our question is we need to find out, what is the future value? Well, we don't know. We have two people. We have Adam and we have Blake. Adam has made a $200 payment at the end of each year. So that $200 goes in. Add our rate, which is 5%, compounded annually, the end of 5 years. So 1 by 5 is 5. Subtracting the 1 all over 0.05 over 1. Adam's future value as I type in my calculator, comes out as $1,105.13. Part B asks, what principal amount did Blake invest 5 years ago? Well, because at the end of 5 years, their future values are equal. Blake's future value is going to be $1,105.13. We don't know how much Blake had put into his account originally, which means we're going to calculate what is his principal. It's using the exact same information, 5% annually. But in this case, sorry, should have also stated, Blake makes a single investment, which means we have to use the compounding formula for only one investment. And then to calculate what our p-value is, we'd have to divide by this, what the p is being multiplied by. Now this would for sure be a perfect case that I want to actually use my $1,005.13, my calculator. Because normally money is not calculated to the point, is not calculated to the nearest 10,000th. He would have had to invest $865.90 in order to get the same amount that Adam did. So who earned more interest and why? Adam had put $200 away one time every year for 5 years. So Adam had put $1,000 away. The total amount that's interest, though, would just be to calculate the difference. So Adam would have $105.13. Blake, though, had the same value, same worth, but he had only invested $865.90. So Blake would have earned $239.23 of interest. So who had earned more interest? Well, obviously, Blake did. But why? Well, here's the reason. Blake had been able to invest a larger amount and leave it in his account for 5 years. whereas Adam was only able to save $200 a year. Because Blake had been able to invest a larger amount, he had a larger initial investment. He was able to earn more interest because he had more money in there every single time. Or he had more money in there for a longer period of time. So yeah, more money in for a longer time. Celia wants to have $300,000 in 20 years so that she can retire. Celia has found a trust account that earns a fixed rate of 10.8% compounded annually. What regular payments must Celia make at the end of each year to meet her goal of $300,000? So I'm just going to write down our formula for a regular because she's making regular payments into this account. So she wants to have $300,000, which means that's our future value. We have to calculate what is going to be the regular investment amount. Everything else we should know. A 10.8% interest compounded annually for 20 years. In order to properly manipulate this equation, we'd have to multiply both sides by this 0.108. So the 300,000 multiplied by that 0.108 will give us $32,400. And to finish off the calculation, in order to get the R by itself, we'd have to divide by this entire thing that it's being multiplied by. So how much is she going to have to put away regularly? Let's type into the calculator. We get $4,781.09. So if she wanted to have $300,000 and she was able to find a 10.8% account in 20 years, all that she'd have to do is put away about $4,800 every single year. With a good job, that is absolutely attainable. The younger that you are to start investing, the less this one amount would be. So for those of you that are 17, 18, if you want to retire when you're 65, you have 48 years to actually put away money, which means if you were able to find that 10.8%, I'm not saying that you would, but if you were able to put even 4,000, even half of this, you'd be able to live quite comfortably the longer if you're able to save for a longer period of time. So that's what our regular payments would be. How much of that would be interest? How much interest would she have earned? Well, she's putting $4,781.09 away every single year for 20 years. She will have put away $95,621.80. That's how much money Celia has actually put away. How much of that will be interest? If it's worth $300,000, I'm just going to have to calculate the difference. Which comes out as $204,378.20. So she would have put in almost $100,000 and she would have earned almost $200,000 in interest. Not a bad deal. If you're going to make a monthly contribution to a bank account on a monthly basis at the current RBC prime rate, how much will you have at the current retirement date? So I would like you to do your own calculation. I'm going to pause the video very quickly to find out what that prime rate is at the current moment. So today's rate, normally used for loans, but today's current rate is 2.45%. So what I would like you to do is calculate your own. If you're only able to put away $50, how much would you have when you retire? So after 48 years. Take the time, do the calculation. I'll continue on. On Louis' 20th birthday, he started making regular $1,000 payments into an investment account at the end of every 6 months. He wants to save for a down payment on a home. His investment earns 3.5% compounded semi-annually. At what age will he have more than $18,000? So our account or our formula, we want to know when will he have a future value of $18,000. Now notice he is trying to buy a home. This is only a down payment. If he's able to put away $1,000 regularly, rate 0.035, compounded semi-annually, we have to solve for the time. So we're going to have to do some manipulation. First thing that we're going to want to do is get rid of that denominator. So 18 grand multiplied by that 0.035 over 2. I know that I don't have a lot of space on here, so I'm going to have to do a little bit of rearrangement. Minus 1. I'm going to then divide by the 1,000. To give me 0.315. So don't actually need that bracket anymore because I don't have anything on the outside of it. 35 over 2. power of 2t minus 1. I have to add 1 to both sides. So I'm going to continue my work up here. So I would have 1.315 oh, sorry. That should be a 0.35. And now here's where it can get a little bit trickier. It gets a bit trickier because we need to try and work this out. Now, the one thing that we can do is we can take the square root of both sides. So square root of my 1.315 works out to be approximately 1.1467. But taking that square root only will cancel off that 2. We would still have the 1.035 over 2 still to the power of t. Now let's just do a quick evaluation. The one adding the 0.035 over 2 comes out as 1.0175. So we have 1.1467, so on and so forth, equaling 1.0175 to the power of t. So what we need to do is we need to do some trial and error. Trial and error. I gotta make that actually look like it says trial and error. So a trial and error comes into what does it come out? 1.0175 to the power of what gives us something very close to here. We're not going to have something exact. So we're going to have to try our best. For example, if we did 1.0175 to the power of 6, we only get 1.1097. Not quite close enough. But if we do 1.0175 to the power of 9, lost my calculator, we get 1.168987, and now that's too high. So one other thing that you need to be paying into account or pay attention to is that it's compounded semi-annually, so meaning every half year. What we can test out is every half kind of year. If we went to the power of 7, we get 1.129. If we go 7.5, we get 1.13895. It's getting closer. 1.18 or 1.0175 to the power of 8 is 1.1488. So I'll just round to 89. This is our closest. Which means that t value equals 8. So the time in years is 8 years. At what age would Louis have to be then? He'd have to be 28 years old in order to save that $18,000 for that down payment for his house. And there you go. Have fun.